everybody. Thank you for attending today's class and for tuning in this video format. Today, we're going to be starting in a different direction in the R class. So far, we've covered the basics of objects, vectors, and functions, as well as the basics of working with data and the grammar of visualizations using ggplot. That's a lot. So congratulations, you've learned a lot. So using these tools, we can actually do some really cool things. And that's what we're going to be talking about today, how we can combine all of that knowledge from past weeks and do some magic. But before anything, let's get our data loaded in as usual. So today we're going to be working with a new data set, river_data.csv. So please load it in as usual with the my data equals read.csv, in this case, in quotations, remember. Any string of text has to be in quotations or R won't recognize it. river_data.csv. And we're also going to need dplyr today, which, if you remember, is our favorite data transformation package all the way from week 3. Okay, so this river data set, I'm just going to briefly go over what it's all about so that when we're working with it, you have an idea of what we're actually doing, what we're actually seeing. So the river data set is looking at a river from the upstream headwaters all the way down to the downstream mouth of the river. For each site, data were collected on various parameters like temperature, pH, dissolved oxygen, salinity, and conductivity. Okay, so now that we have our data ready to go and we have a basic idea of what it's about, let's talk about functions. So why would we ever want to make our own functions when R is chock full of its own? Well, why is this important? If you know how to make your own functions, you can ask R to do anything you want. You're no longer limited by defined functions like median or filter. It will give you so much freedom and flexibility in the future and allow you to carry out the exact analysis you want instead of just defaulting to the auto calculations done by predefined functions. And finally, it will save you a ton of space in your code, as instead of having to type the same thing over and over and over again, you can just make one function that does it for you and then just use it for each of those cases. If you've worked in other programming languages like Python, you will understand how important making your own functions is. And to build up to this, there are a few things we need to understand. We're not going to just jump right into making functions, but we're going to do some of the groundwork first, so we have a really solid foundation to build on. First, if-else statements. If I'm home by 7, I'll make dinner. Else, make it yourself. Pretty straightforward, huh? This is an if-else statement. It gives one possibility if the condition is met, and then another possibility if the condition is not met. In this case, the condition is me being home by 7. Because I'm not cooking dinner after 7. That's too much work. We can expand on this a little bit more. Here we go. If I'm home by 7, I'll make dinner. Else, if I'm home by 8, I'll bring takeout. Else, make it yourself. So here you see what we're doing is we're adding in this in-between else if. And we can add as many of these as we want. Else if I'm home by 9, else if I'm home by 10, all of that, all the way to our final else. So this allows us to take lots of these different conditions and then go in order to see preferentially I'd make dinner, but only if I'm home by 7 in each of these. So basically, the else if is giving another possibility if the last one's criteria was not met. And then the else is just a catch-all at the end for anything that fit none of the criteria. If I don't even come home that night, that's fine. Just go to the last condition. If I come home on Saturday, yep, last condition. So let's actually try this in R. We're going to be using info across many weeks, so this should also act as review for you, hopefully, and practice. So keep that info alive in your brain. First, let's add some objects to the global environment. I want you to create an object, Patrick. And Patrick equals 25, and Bertha equals 40. And these are going to be the ages of these people. So please do this, and make sure they pop up in your global environment. Also, please make sure you actually do use these numbers and not different ones. It'll be a little bit important down the line. So just type in your R, Patrick equals 25, and Bertha equals 40. Give those a run and make sure that they pop up in your global environment. Okay, so now that we have that, let's build our first if-else statement in R. First, the if. If Patrick is bigger than Bertha, that's our condition. So basically, if Bertha is older than Patrick, because remember those values represent their ages. So if Patrick is bigger than Bertha, then we do our curly brackets to indicate a code block. So in my code block, I put 1 + 1. Basically what we're saying is if Bertha is a bigger age than Patrick, calculate 1 + 1. So give this a go. And you should be seeing, hopefully, that R will just calculate that 1 + 1 = 2, as Bertha is, in fact, older than Patrick. And please do make sure that you're following along as you do this. Have a tab open in R, have a script, and make sure that you're going through and practicing and trying all these things, leaving lots of notes with hashtags. I know it can be a little bit more difficult watching a video than actually attending the in-person class, but hopefully this way you'll be able to just get that practice in. And you can always email me if you have any questions. That's what I'm for. Okay, so what if we flip it? What if we run the opposite? If Patrick is bigger than Bertha, calculate 1 + 1. What happens? Give this a try. So you should be finding that nothing is happening. The condition for the if statement was not met, so the code block was not executed at all. So that's what happens if an if condition is not met. Just nothing happens. So anything in the code block is only used if the condition, in this case, Patrick greater than Bertha, is met. A handy function we can use in these statements is print. So see what I've done here. I've used print, and inside print in the code block, I specify the text that I want in quotations, because remember, it's a string of text. So if Patrick is greater than Bertha, I want R to print Patrick is older than Bertha. So it's just a little handy message that we can use within the code block for R to use. So please give this a try and see how print works. So if you've been paying attention so far, nothing should happen. Nothing at all, because Patrick is not bigger than Bertha. Bertha's way older. So R is going to look at this and say, well, the condition is not met. I'm not going to do anything in the code block. So here's where we can bring in our else. Else is quite handy. Remember, if I'm not home by 7, I'll cook dinner. Else, do it yourself. So now we're going to put in that do it yourself section. Okay, now we're talking. If Patrick's bigger than Bertha, print Patrick is older. Else, print Bertha is older. So we have a little clean little logic flow here. Please give this a try and see how it works. Now you should be finding, if everything's working, that R will print the message, Bertha is older, which is really cool because they could be any ages, right? And then we put them in here and find out which one is older. Sort of. There is one small flaw with our code. You may have realized it. What happens if Patrick is 40 and Bertha is also 40? What if there's a tie? What if they're the same age? Let's give that a try. Just beneath that code, I want you to redefine and overwrite the Patrick and Bertha variables. So just write beneath all of that, Patrick equals 40 and Bertha equals 40, making them the exact same age. And while you're doing this, I want you to think, what are you expecting to happen when you run your if-else statement? What do you think? How do you think R will interpret this if neither of them is older than the other? So please try running your if-else statement again. Just copy it and put it underneath and try running it again with the new ages. And you should get the message, Bertha is older. Why? Well, that's because we said Bertha is older is the else case. That's what R will do in any case except Patrick being the older one. So that's no good, right? That's not very good logic. We don't want R to be doing that. So now we get to bring in our else if to help solve this problem. Here we go. This statement actually covers all the possibilities. If, oh, and you know what? I'm going to pull out my laser pointer for this. If Patrick is older than Bertha, in our code block here, we want R to print Patrick is older. Else if Bertha is bigger than Patrick, we want to print Bertha's older. Else, so if none of those are met, we want it to say Patrick and Bertha are the same age. So this will cover all three of those possibilities in our if-else statement. So please run this and see what you get. And of course, what you should be getting is the message, Patrick and Bertha are the same age. Good job. Okay, so here's something that I want to do with the river data. We're moving on to working with our actual data here. I want to know if there's more data collected in the wet or the dry season. And I want to print a message saying by how much. So let's go through this together. If we have more data, more rows of data from the rainy season, I want R to print rainy minus dry. Okay, so basically this is, when I'm saying rainy season, I'm meaning the number of rows of data collected. So if there's more rows of data collected in the rainy season, print the number of rows in rainy minus the number of rows in dry. So that's showing the difference, right? Else if there's more data collected in the dry season, I want to print the number of dry rows minus the number of rainy rows, and that will again give us the difference. So we're saying by how much, right? And then else, I want to print a message saying that there is an equal number of rows. So we made sure that we have our tight three sections of logic. So if rainy's bigger, if dry's bigger, and then if they're equal. But how do we go about doing this? Because obviously this is a lot more complicated than just having two values of 40 and 40. So let's go through this together from the top and we'll see what we can do. So first, I want to create some values to use. Remember, we created the values Bertha and the values, oh, Patrick. Patrick was his name. I don't know what I was about to call him. Patricia? No, Patrick. So we had those two values, Bertha and Patrick. And what we did is we used those values inside the if-else statement to create our logic. So I kind of want to do the same thing here. I want to create the values dry and wet, which store the number of rows collected, because that will make our lives a lot easier. So first off, the dry season. I want to know how many rows of data were collected in the dry season. Now we can use a couple functions here to do this. How many rows of data? Well, we have this handy dandy function called nrow. Nrow is really useful because it takes in any data frame inside as the first parameter here, and then it tells you how many rows of data it has. Nice, very elegant. Collected in the dry season? Well, here, I'm hoping we're going to remember all the way back to week 3, data transformations. We can use filter. Filter is a dplyr function that allows us to take in any data set and then filter it so it only has the data that meets a certain condition. So of course, we want to filter the data to only be from the dry season. Filter, my data, season equals equals. Remember the 2 equal signs means that you're asking R to check if it is equal to this thing exactly, and then dry in quotations. We're going to do a capital D here and a capital S here because that's how it shows up in the data sheet. If season was written with a lowercase s as the column name, we would make sure it's a lowercase s here. This is where a lot of us keep stumbling in R, is not paying attention to the capitalization. It seems like a small thing, but R reads capital S season and lowercase season as the exact different things. Okay, so in filter, we're specifying the data set, and nrow counts the number of rows. So all we have to do is combine them. And this is using function nesting, which we learned about in week 1. What a blast to the past. So nrow on the outside here, and then filter my data season is equal to dry. So we're taking the number of rows in our filtered data set that only has dry season data. I think it looks pretty nice. Okay, and finally, we're assigning it the name dry, so it saves to my global environment. Please make sure that you are doing this and check that dry actually shows up in your global environment attached to a value. So go ahead and do that. And after you've done that, please do the same thing with the wet data. Create an object called wet that stores the number of rows of wet season data. All good? Okay, now we're ready to build our if-else statement. So if you remember, first we want to say if there's more rainy season data, then print rainy minus dry to get the difference. Okay, so we have our values now. We have wet and we have dry, which would represent these. So how are we going to do this? Well, I'm hoping that you guys will give this a try on your own, okay? So please fill in the code below so we can print the difference between rainy and dry data if rainy data is greater than dry data. So please think about this a moment, pause the recording, and just give it a go. And hopefully you've given it a chance. And basically we should get something like this. If wet is greater than dry, wet minus dry. And this is our code block here. So we want R to calculate wet minus dry if this condition is met. It's a lot shorter than I would expect it to be, which is really nice. And we can also do multiple outputs in the code block too, because right now, just calculating wet minus dry isn't really doing too much for us. So what I'm hoping we can do is multiple outputs to make it a little bit more useful with a message. Now look at this. If wet is greater than dry, print, there is more rainy season data by this many rows, wet minus dry. So by doing this, and of course I would like you to try, we should be getting this result. There is more rainy season data by this many rows, 32. So it's now becoming a much more useful and informative function. And that's great. That's great, because using as much code as we can in here to relay information to us will make our custom functions custom. Because we want to tailor them to do exactly what we want, to impart the exact information that we need. And using these little messages combined with data that it's calculating can be really handy. Okay, now you guys are up to bat. Please fill in the rest of the code to make a complete if-else statement. So remember, we want to cover all the possibilities. We want to cover if dry is greater than wet, if wet's greater than dry, and if they are equal. So please, using the example of Patrick and Bertha, go through this and add in little print and calculation messages for each of these to cover all of the possibilities. And once you are done with that, this is an example of how I did it. This is a version of the completed code. Your messages might vary slightly. Oh, and actually, I'm noticing I forgot to put in dry is greater than wet here. So that's a slight oversight, but hopefully you guys didn't forget that and you are getting the correct result. So it should look something like this, but there should be a condition in here. So good job, guys. However, you guys are doing great. You're doing great, but we can take this further. So I have a whole long list of different locations sampled out on the river. What if I want to run this if statement to see how it goes only for location 1? Is there more wet or dry data for location 1? Or only location 2? Is there more wet or dry for location 2? Or say I wanted to use our if-else statement to see if there's more rainy or dry season data at upstream sites versus downstream sites, or it's sites with high pH. Well, all of that sounds really interesting, but the way we have our statement set up is not really conducive to getting that sort of information. Our current setup is like a simple machine. It takes in rows of wet data from my data and rows of dry data from my data, feeds it into our little if-else machine, and then we get an output. So it's very simple. But what if we could use a much cooler machine? This machine, instead of just taking wet and dry rows from my data, it takes it from any data set we want. Very nice. So it takes wet rows from any data and dry rows from any data, feeds it into this cool machine, and then gives an output. So this, my friends, is a custom function. Finally, we've hit it. Okay, so let's take a break from this river data puzzle from now. We will come back to it later, though. And let's talk about custom functions. Here's the basic format for custom functions. So we name it. We have to make sure that we name a custom function. Otherwise, we won't be able to call it later and actually use it. So in this example, it's called my_function equals. And here is our magic little code that will create the function. And then in the brackets here, we're putting our parameters. And then the curly brackets, we're putting our code block. So like I said, this is our name. We gave our function a name so we can actually use it. Any name that you want. And then here are the parameters you want to be able to put in when using the function. For example, remember the function mean, and inside mean, you have to put a list in the parameters, a list to take the mean of. So a list would be the parameter needed for the mean function. You would put list in here. But in other cases, you might want a number. You might want a data frame. You might want something super specific like temperature. A temperature value has to go in there. And you're going to do something with it, like find out what 35 degrees Celsius would be in Fahrenheit. So you need it to put in a temperature. So it's anything you want, a parameter that you need to actually use your function. And then, of course, we have our code block where we put what the function is actually doing. Here is a really simple example. My newest creation, it is called half function. The sole parameter for half function is a number, so I need any number to be used with it. And what the function does inside the code block is it divides the number by 2. Number divided by 2. I can then use it like any normal function because it's saved in my global environment by naming it like this. For example, half function 4. So I'm putting 4 in as the number. And then what R is going to do is it's going to execute this code block using that specific number. So R will calculate 4 divided by 2. So please give this a try and make sure that everything works according to plan and that you see half function pop up in your global environment. And I really want you to take a look at how it displays in your global environment because it should show you the parameters that you need. So please give that a go. Okay, so your next task is to create a function called times3 function that multiplies an inputted number by 3. You can use my amazing complicated half function code as a guide if you like, but I want you to do times3 function. And please also test out your new function to make sure that it actually works. Pick any number and see if it will multiply it by 3. So please give that a go. You should be getting something like this. It may vary slightly. You may call your parameter something different, but it should work something like this. Times3 function equals function, takes in a number, and then in the code block, we want number times 3. And here's an example of using it. Times3 function, 4, and it will calculate 4 times 3. Very nice. Okay, so how do we take what we just learned here on custom functions and apply it to what we just did with the dry and rainy season data? Okay, I'm about to show you a lot of code, so don't panic. This is what we just did with our wet, dry season puzzle. This is all that code we just spent all that time making. First, we defined dry by taking the number of rows from dry season data. Then we defined wet as the number of rows of wet season data. And then we wrote our if-else statement that should have a condition in here. Again, my apologies. So if wet is greater than dry, there's more rainy season data by this many rows, et cetera, et cetera. So we just did all of this. And what we want is a custom function that will take all of this code and run it for any data. But right now, it's just running it for my data. So data is the key here. We want data to be whichever data we want, but right now it's just limited to being my data. So what we can do is make my data the parameter of our function. Turn it into just any data instead of just my data. So in the function here, let's call it wet dry function. We use data as a parameter. So we can put any data set in here. We can put data that's just upstream sites. We can put data that's just downstream sites. We can even put my data in, like the same full data set that we've been using all this time. Any data can be filtered in here. So then what goes in the code block? Well, I'm glad you asked. That'll be all of this. Everything that we just did, all that work, we've already done it for the custom function. But with one extremely important key difference, my data now becomes data because it's a parameter instead. We're not just doing it for my data, we're doing it for any data. So we take all of this code that we just wrote, and we're gonna plop it right inside the wet dry function. I'm kind of running out of space in my slides here, but I'm sure you get the general idea. Our wet dry function equals function, and it takes in any data, and then curly brackets indicates the code block, and in the code block is our if-else statement, as well as defining dry and wet using data, using that any data. And then it should give us one of these outputs, depending on what the data is like. Okay, phew. So yes, here I just have a couple slides showing defining the function is our first part. And then our assigning two objects, dry and wet, is our second part. Then our if-else statement is the third part, which is determining whether there's more rainy or dry data and by how much. And then this is the complete thing. So please, yes, enter this code into your R so you have it in there. You should be able to quickly do that by just copy pasting your if-else statement, changing my data to data, and then adding in the skeleton of the function around it. So go right ahead and do that. And now that that's done, now that you have that function defined, let's actually use it. Let's use it for something more exciting than just my underscore data. I have 4 tasks for you guys. I want you to use this new function on these filtered data sets. The 2019 data only, so only data collected in 2019. Only data collected by collector A is number 2. Number 3 is only data collected where pH is less than 7. And then number 4 is only data collected in February. And for each of these, I want you to run wet dry function. And if you're feeling a little overwhelmed or stuck right now, how on earth do I do this? Here is a little example below. If I wanted data only collected in 2012, this is what I would do. Wet dry function, and then it wants any data set, right? That's the parameter, is any data set. So in it, I'm putting a filtered my data where year is equal to 2012 using our dplyr filters like we did at the beginning. Okay? So using this as an example, I want you to please do each of these, and you should be learning whether each of these filtered data sets has more wet or dry data and by how much. And if you need the full solutions for any of these and the answers to just check your work, you can always use my code example, which is on the drive. Okay, so hopefully you had no trouble doing that. Remember, you can always email me if you have questions or check my example code. Now it's time for the big one, the final challenge of today's session. I want you guys to create a function that checks mean salinity of any data set. If salinity is greater than 3, I want R to print salty, else print not salty. And I want you to use this function only on downstream sites and then only on upstream sites. So there are 3 separate things we're doing here. First, we're defining the function that checks mean salinity and then prints either salty or not salty. Second, we're using it on downstream sites. And third, we're using it on upstream sites. Okay, so good luck with this one. I know it's a little bit more challenging. Don't forget your function mean, which takes the mean of any list. And don't forget, for downstream and upstream, we can filter our data using dplyr. So take some time with this, give it a go, see what you can come up with. And I will like to mention that there are multiple solutions for this. When I worked with a student on this on Friday, and we found that he did something entirely different than my solution, and it still gave the exact same output. So just think about that as you're going through it, that there are multiple ways that we could be doing this. And here is one example of what the solution could look like. Here I'm defining the function salty. Salty takes in any data, and then if the mean of the salty column of data is greater than 3, print salty, else print not salty. So very simple, very elegant. The only part here that might have tripped you guys up is this, the mean data $ salinity. So we talked about using the $ as a way of isolating a column quite a few weeks ago. So I'm hoping that you guys would remember that or have it in your notes. If not, this is a great example of practicing and why it would be useful to isolate the salinity column. So we can take the mean of the salinity column. And then we want to check if that's greater than 3. That means salty. Okay, so that's my function. And then finally, I am checking it for position is equal to downstream and position is equal to upstream. And what you should be finding, of course, is that our downstream is salty and our upstream is not salty. All right. And with that, that's all of the material that I have for you guys today. So I hope you found this useful, and you can always reach out if you have any questions or concerns. And I hope you guys all have a wonderful day. Bye.